Hi guys, and welcome to another video. Today we're going to be looking at graph sketching, calculus. So let's look at this question which came out in the February-March 2013 examination. It says given f of x equals to minus x cubed minus x squared plus x plus 10. It says write down the coordinates of the y-intercept of f. Now to find the y-intercept of f, all you have to do is make x equals to 0, because at your y-intercept, remember, x is equal to 0. If I make x equals to 0 here, I'll only be left with positive 10. Therefore, the y-intercept will be 0 and 10. So for 10.1, the y-intercept will be 0 and 10. That's our solution. Remember, to find the y-intercept, we substitute x equals to 0. 10.2. Show that 2 and 0 is the only x-intercept of f. Now there are two ways in which we can do this. We can do this using our calculators, but remember it's for 4 marks. Okay, so let's show some working. So for 10.2, I'm going to say, remember that if 2 and 0 is an x-intercept, that means that f of 2 equals to 0, therefore x minus 2 is a factor. So, well, the first way in which we can do this is we can use synthetic division. But we can say that 2, and now let's put down the coefficients of f for each term in this particular function, including the constant term. So negative 1, negative 1, positive 1, and 10. So we got negative 1, negative 1, positive 1, and 10. Now remember that negative 1 is a coefficient of x cubed, negative 1 is a coefficient of x squared, positive 1 is a coefficient of x, and positive 10 is a constant term. So remember that 2 is now a root. So therefore, to do synthetic division, that would now be 0. So we are now looking at this here. So now let us complete our synthetic division. So we're going to add minus 1 plus 0 is minus 1. And now we're going to multiply. So 2 times minus 1 is minus 2. Add minus 1 and minus 2 is minus 3. Now we're going to multiply again. 2 times minus 3 is minus 6, and we'll get minus 5. Remember that you're adding down, okay? Then 2 times minus 5 is going to be minus 10, and add 10 minus 10 is 0. Remember, you must get 0 here, otherwise this particular value of 2 will not be a root, and therefore x minus 2 will not be a factor. But in this case, because that is now 0, remember 2 is a root and x minus 2 is a factor. Now what does this prove? Well, it proves the following. It proves that we have x minus 2 into minus x squared minus 3x minus 5 equals to 0. So basically what we've done is we've factorized already. Now they said that prove that only x minus 2 is a factor. Well, they told us to show that x equals to 2 is a root. Now that means that in this particular quadratic that we have here, minus x squared minus 3x minus 5, we would have no real roots. How can we show that? Remember, delta, which is our discriminant, equals to b squared minus 4ac. Therefore, b squared, that will be negative 3 squared minus 4 times minus 1 times minus 5. And that's equal to, so minus 3 all squared is 9. And now this will give us minus times a minus times a minus is minus. 4 times 5 is 20. So what do you notice? 9 minus 20 is minus 11. So because you got minus 11 as your discriminant, means now that you've proved that we have no real roots. So you got no other roots. So that means that only x, therefore x minus 2 equals to 0. Therefore x equals to 2 is the only root. Okay, so basically that's how we can show that x equals to 2 is the only root. And here we've used synthetic division. Alright, now let's look at the next question. In the next question, we have following. It says calculate the coordinates of the turning points of f. Now remember, to find the turning points of f, we need to say that f prime x equals to 0. The derivative of your function equals to 0 at your turning points. What happens at your turning points? You're either going to get a local maximum or a local minimum. And what happens at your local maximum or local minimum? Your derivative of your function is going to equal to 0. So therefore, let's find the derivative of this particular function, and the derivative of this function will be minus 3x squared minus 2x plus 1 equals to 0. Let's double check. We're using the rule, remember? 3 times minus 1 minus 3x, subtract 1 from there, so it will be minus 3x squared minus 2x plus 1 equals to 0. Right, so let's write that down and let's see if we can now factorize that. So minus 3x squared, let's get that number there again. The number is 10.3. So in 10.3, let's write that down, and that is minus 3x squared is 2x. So minus 3x squared minus 2x minus 2x plus 1 equals to 0. Minus 2x plus 1 equals to 0. Now let us factorize this. So once again, if I take out minus 1 as a common factor, I'll be left with 3x squared plus 2x minus 1 equals to 0. Well, I could have just divided or multiplied by negative 1. So I'm going to get 3x squared. Remember, now if I divide by minus 1, this minus 1 here would now disappear. Okay, so 3x squared plus 2x minus 1 equals to 0. Let us factorize. So we'll say 3x times x is 3x squared. Here we got 1 times 1 is 1. Let's get our signs right. So this will be plus and minus. Let's double check. 3x times x is 3x squared. Minus 1 times plus 1 is minus 1. Minus x and plus 3x gives us positive 2x. So therefore, 3x minus 1 equals to 0, or x plus 1 equals to 0. Let's solve for x to get the x values of our turning points. 3x equals to 1, x equals to 1 over 3, and here x equals to negative 1. So these are the x values of our turning points. Now in order for us to get the y values of our turning points, we now have to substitute these values into our original equation. And for that, we're going to be using our calculator. So let's go back to the original function. Remember, we're going to substitute 1 over 3 and minus 1 back into our original function. Remember, to get your y value, you always have to substitute back into your original equation. So let's look at that. Here, got following. Okay, so if we have to substitute minus 1, so we got minus 1 minus minus 1 all cubed, so minus minus 1 all cubed, so that's taken care of, and then minus minus 1 squared plus minus 1 plus 10, all done. And now let's see what answer we get there. So the answer that we got is 9. So therefore the y value there is going to equal to 9. So we got negative 1 and 9. Now let's go substitute 1 over 3. Okay, so let's put 1 over 3 here. So we got 1 over 3 over 3. Okay, so remember we're substituting back into the original equation. 1 over 3, right, and equals to, and here we got 275 over 27, and let's get the decimal because, right, we're going to sketch the graph just now, so that's 10.19, so that'll be 10.19. If you wanted to, you can also write down the fraction, right, as well. So therefore you're going to get turning points as 1 over 3 and 10.19, and over here we got minus 1 and 9. So those are your coordinates of your turning points. Okay, now they're telling us in the next question, they're saying that after finding the coordinates of the turning points, it's saying sketch the graph of f in your answer book, show all intercepts with the axis and all turning points. So let's look at that. So in 10.4, let's sketch this graph. So here, let's have a look at that. Okay, so that'll be my y-axis, that's my x-axis. So I'm not going to draw this graph to scale. However, I'm going to try and include all of the necessary points. Let's start off by putting our x-intercept, which is, and y-intercept. So our x-intercept, remember, is 2 and 0. There's it here. So I'm going to put the x-intercept, and I'm also going to put in the y-intercept, which is 0 and 10. So the x-intercept is, right, remember I said I'm not drawing this to scale, so 2 and 0, so that's 2, and let's put it here 10. Okay, so that's the y-intercept. Then the next values that I'm going to put in is the turning points, right? So there's it up here. Okay, so 1 over 3 and 10.19. 1 over 3 and 10.19 would be, let's estimate it to be somewhere there, right? 1 over 3 and 10.19, and then negative 1 and 9. Negative 1 is here, minus 1, and 9, let's say, is somewhere here. Okay, so let's say that 9 is here. Right, now, very importantly, let's go and look at this particular function that we have. So the function here is, remember, the coefficient of x cubed is negative. Remember, a is less than 0. Now, if a is less than 0, let's write it here. A is less than 0. Your function is going to be a decreasing function, which means it's going to start off by decreasing. So it's going to be negative, positive, and negative. Remember, negative gradient means the function starts off by decreasing, then increasing, and decreasing again. So that's going to be the shape of your graph. So therefore, in sketching this particular graph, we will now have the following. So it's going to go down, there you go, up there, through the y-intercept, at the turning point, coming back down past that. So there you go. This is now going to be your graph of f. So once again, remember that minus 1 and 9 is that turning point. One turning point, the other turning point is 1 over 3 at 10.19. The x and the y-intercept is also shown. And basically that would be your graph of f. Learners, this is a typical examination question on sketching of graphs. An alternative is that if you don't want to use synthetic division here, you could very well use a calculator and try to show as much working as possible. If you haven't subscribed already, please do subscribe to my YouTube channel and also check out all the videos on jrmaths.com. And I'll catch you in the next video.